The next speaker, and one of the most important qualities of artificial and natural intelligence that we expect from the artificial one is the ability to speak natural human language. And up to recently, communication in natural human language with AI was made through different workarounds and even different hardcore patterns and scenarios, but as of today, there is a certain promising trend of a breakthrough on the basis of GPT-3 and next generation of these networks. So question to the next speaker: how true can we deem it a breakthrough? How well is it applied to AI, and how well can we structure the systems of natural language processing developments without using hardcore intents or anthologies? So our next speaker is V.Ternovsky from Sber, who will speak about the future of dialogue systems, new implementations of ruGPT-3.
Thank you, Anton. Hello, dear colleagues. I'm V.Ternovsky. Together with our team, we are in developing dialogue systems based on large-scale modern architectures, and I will share with you our successes and lessons learned in development of networks of that type. And I will share with you my observations and maybe some helpful tricks. As for the structure of my presentation, I will begin with the problem setting, on how we plan to use our dialogue systems, what are the nuances and business tasks, and then I will move to the technical side. Out of the blue, we will find out that metrics and data are very important for machine learning, and I will share with you a little bit about our technology and share our experience. So, Sber recently offered like the line of virtual assistants called Salute. You can chat with them right now and give them orders, know the set of their skills, so either in Sberbank Online or in Salute, the mobile app. The point was, the goal was to create a seamless system that could have dialogue with a human being. So we have three critical characters. They are not just icons, but we want them to be different from each other in communication style, in vocabulary, in the ability to be in a dialogue. We wanted them to be different experience for people who communicate with the intellectual dialogue systems. So the key change is that we moved from a transformer model ruGPT-2 to ruGPT-3, and the key difference is data the network learned. GPT-2 mainly used literature, Wikipedia, news, and so on. And GPT-3, in turn, was trained not just on literature and news, but also on different data from the internet, code, and the amount of data grew 3 times, and according to our metrics, the point was not just to set the other architecture, but also to take some additional actions to improve the dialogue, but our metrics grew up by about 20%, I mean dialogues, after we moved to GPT-3. As for the metrics, it's a serious issue when you train dialogue systems, because it's clear that automatically for classification it's difficult to determine how efficient the system is in delivering the dialogue. Yeah, because there is no metric showing whether the network is surprised. But to find the correlation between the perplexion and the quality of observing the dialogue is impossible. So we used a number of metrics, SSA offered by Google Mina and Acute Evil offered by Facebook. SSA is an absolute metric that shows to assessors, real people, some sets of dialogues, and we ask them to assess whether answers are relevant, and we can compare it. And acute eval is easier for assessors, but it's not no transitivity. It's possible to use model-to-model dialogue, and we think on how we can formulate a question better. So here you can see the way a task looks like, so people assess what model would you prefer. So what model would you prefer for a long conversations, who is more interesting, and you see dialogues. Based on this pair of metrics, after every series of experiment, we make the decision on what model is better and where the dialogue has higher quality. Now, about data. As I said, the basic language models, they contained huge amounts of words, not just in Russian, but other languages as well. But what we found as a result of our experiments, the crucial element of the entire dialogue system learning architecture is the target data set. What is it? Of course, you can take a model and learn it on a super data array, like dialogues of users, comments in social media, or some dialogues from literature, or captions from movies, and the model will learn how to lead a dialogue, but it's very difficult to get to the desired quality of communication, because there is a lot of content hidden, and we have some wonderful models we used to enrich the target data set of just 3,000 coined sayings. Well, it looks like it's not that much, but there we use the vocabulary we want our virtual assistants to use in communication with people. So, in some sense, it's like a simulation environment of interaction between the user and our dialogue agent. We use this target data set. We know it's good. All content is good there. So that's how we get the dialogue system for user-bot interaction and improve it. A little bit about the architecture. GPT-3, and I will be brief, here. The autoregressive language model only with decoding blocks and attention masks. So we predicted token by token. It's not possible to say where our generation would go. So it's something charming, but also dangerous about models like this. We can continue the dialogue with the user, but we don't know where the model and where and how the model will lead it. As for modifications, you have the graph. So we added next sentence prediction head. It's a classifier that allows a model just to sort between good and bad sentences. And for every step, we add like a wrong sentence, and we make model to tell between them. And we don't only have the context, but the vector that describing character for which we get the model. We have 3 characters, as I said, in Salute virtual assistant, and we also have one solo model which is able to answer on behalf of every character. Well, it activates a bit of embedding, like Joy uses informal language and Sber formal. As for our training pipeline, so it's difficult for GPT-3 and some parameters for training are here. It's not possible to share with you everything. Then we take the language model that knows a lot about Russian language, the structure of the language, semantics, and we need to show, well, it has about 50 gigabytes of dialogues. We take them from books, and we teach it how to deliver a dialogue, teach her, and then we teach it in a supervised mode, and we get the solution we need. This we also have like a reference books of hints and areas that result in something positive, can be summarized as this list. Also, bad sentences could be added to the learning process randomly. You can access another dialogue occasionally, or another trick. We can take the previous generation of models, change generation parameters. It's a big topic for the model, and we make it generate answers for the content we know which would not be good, which would be inferior to actual sentences from editors. And we do a mix, and it allows us to correct behavior of the next generation of models compared to previous generation of models, so we can call it generative negative samples. Also, we noticed that for generative language models, they tend to hang about. It's about architecture. There are some tricks on how you can fix them in an article about CTRM, but manual correction can affect output logic dramatically, and parameters needs to be chosen carefully, and you need to pay attention to that. Another trick that allowed us to enhance our metrics is ranking output candidates. When we generate sentences of a model, as I said, we can improve generation output if you generate not just one sentence, but 10 sentences, and then you use smaller model trained differently that would select one single sentence out of 10, which is better depending on the actual context. Also, the production story. ONNX runtime library from Microsoft allows to speed inference up to 3 times, and we are happy about this. And for the future, you need to know that offline reinforcement learning, and you see the link to the article, it really works for model metrics, and we get some very promising results. And the key point is that anyway you need correct, accurate, and good data. Some examples of conversation with dialogue models. Well, of course, we are limited in time. I could probably show you more cases, but, well, I would welcome if anyone who is interested uses Salute virtual assistants, and we look forward for your feedback. It would be happy. You can also get more information on Sber blog and Sber Devices VC blog, and we plan a workshop later tomorrow. You are welcome. We will have a more detailed discussion. So I am finished. Thanks for your attention. Your questions, please. Valery. Many thanks. We have a question. Is this statement correct that the trend of technology is about fitting of models for making their dialogues close to human dialogues based on sorted data sets, which is well, a little bit distant from the system. Well, the situation when we launch a system put online which starts to use human language. A good question. Of course, the current state of technologies statistically is about approximation, because statistically our models learn, well, it looks like human learning, but without any cognition. We have a huge amount of parameters, and they allow us to improve semantics. No, but at the moment it's difficult to call it AGI, that we can launch it to the internet and it will live its own life, but at least we can fix and fine-tune pipelines in a statistical paradigm. We can understand it for us, what's important for such systems, what are the details, what's particular about data we've shown. And before, we heard that our colleagues talked about back propagations and alternatives for systems learning, and I believe that in the part with data we focus on now will be applicable. We believe that the industry will develop further on, and we will try other approaches as well, not just statistical one. Okay, many thanks, Valeria. Good luck to you.